Okay, right. Let's modify this question a bit, right? So previously we solved this problem for the entire interval, which means minus infinity to plus infinity for all x values, right? But now I'm going to restrict x values from plus 2 to 7, which means I'm focusing on only focusing on this part, 2 to 7. For those x values, focus on y values or function values. Then compare those function values to get the highest or the greatest value. That is the maximum for this interval. For example, we can draw vertical lines for these values. So that's the function value for x equals 2, for 4, for 6, for 7, like that. Then what's the greatest, the highest function value? Clearly, you will get the greatest value when x equals to 2, when x equals to 3, and when x equals to 4. And also, basically, for all the values between 2 and 4, you will get the maximum value. So if I restrict this interval further down to this 4 to 7, then clearly we can write the maximum value, because that way we can identify the maximum as a single point. That is when x equals to 4. So the maximum function value equals to this height. Can you see that? This height. That height equals to this height, that is 2. So the function value is equals to 2, maximum function value. And for what value of x is the value of f of x at its maximum? But we are talking about this interval. I think when x equals to 4. So we can summarize this idea. F of 4 equals to 2, but that's the maximum value, right? Similarly, for that same interval, let's compute the minimum. 4 to 7, the minimum for that interval. I think very obvious. For that interval, 4 to 7 interval. So clearly we are focusing on negative values, right? Because for the minimums, I think the lowest point is this one. At that height is the minimum. Basically, this height or this height. That equals to this height, that is -1. So the minimum value equals to -1. And for which x value? When x equals to 6, you will get the minimum x value. But here again, we are talking about this interval, 4 to 7. Minimum f value equals to -1 when x equals to 6. You will get that. We can express that like this: f of -1 f of 6 equals to -1. So 6 is the input value, -1 is the output value. Now think about the minimum value of for the entire -infinity to +infinity, that for entire region. Bit tough. Actually, it's not possible to compute because we don't really know the behavior of this function as we move towards infinity, negative infinity, right? Like that. So that's why we restrict intervals, right? So yeah, so to compute the minimum value, we need that restriction. So for example, if I restrict this domain, basically x values, like this, what do you think? For example, let's restrict our domain like -2 to +7. Then for that interval, you can compute the minimum. That's again a -1, that point. So that's the idea. But if I restrict this domain like -4, okay, let's try this. -4 to +6. Now I need the minimum and also maximum. Let's compute minimum initially for this time, for this interval. So I think it's better you can color the region, color the domain. Domain means the x values, right? All the x values. Right now we are talking about -4 to 6. So I'm going to highlight that part, -4 to 6. So now compute function values for each x value, then compare those. Then what's the minimum value? That is the minimum value of f of x. So we can easily draw few vertical lines like this for each value, then compare to get a minimum value, right? Positive values can't beat negative values because negative values are lower, less than the positive values. So I think we should focus on two values, I think, two candidates. This one, this point, and this point. Maybe another point like this. So now let me write those ideas. Here, this height, that's 2, -2 actually. This height equals to -1. I think you can see that, right? If that is confusing, you can draw lines like this. Then that's -1. Here, definitely less than -1, something like, sorry, between 0 and -1, like -0.6 or something. So what's the lowest value? -2, -1, -0.6. I think clearly -2. Lowest value. That is the minimum. Right. So f of x minimum, don't worry about these symbols, right? That is -2. That's the function value. But when will you achieve this function value? The corresponding x value, that is -4. When x equals to -4. We can express that idea in one equation actually. That's the beauty of this. F of -4 equals to -2. And that's the minimum value. And similarly, you can compute the maximum value, but that's basically 3. That's not a problem. I think that's not difficult. We did such things, right? Basically this height, that is +3. So f of -1 equals to 3. That's the maximum value. Just need to write -2 for this, right? Minimum value of f of x is -2. For which x value? -4. Like that. Now I think you can understand, according to that restriction, according to the interval that we are talking about, the minimums and maximums are going to change. Therefore, for a problem like this, you should focus on the X interval, right? Because the entire minimum maximum values depends upon that. Because for example, if I focus on interval like 5 to 7, what do you think? Everything is going to change. So for example, this same problem, if we try to complete this problem for this interval 5 to 7, now what's the minimum? This is the minimum. The maximum point is actually, I think, something like this. That height minus 0.2 or something like that. Completely different, right? So try that. You can experiment. You can restrict intervals and try to compute minimums and maximums by restricting domains, right? Right. Thank you very much.